How does an airbag work?
It's more or less a bag of fabric that is folded. I encountered a project that I could carry out at Volvo Cars. So I live in Gothenburg, where Volvo Cars is situated.
What goes into designing a crash test dummy?
Old-fashioned way was actually to take the bodies from dead people and take them apart and measure the different body regions. I used to destroy my toy cars, and my mom was a bit upset with me. Sweden is such a small country. Everyone knows each other more or less, and people trust each other.
Hello, and welcome to another edition of the Professor Mahesh podcast, your resource to help you make informed career decisions. This podcast is brought to you by IITM Global, an initiative of the Office of Global Engagement at IIT Madras. IITM Global is our platform to help take IITM and India to the global audience, our research, our thinking, our startups, and our innovation. For today's conversation, I'm delighted to have Professor Svensson from Chalmers University. He has spent a lifetime understanding vehicle safety, both the passengers and the drivers inside the car, as well as what makes cars safe in general. It's a delight to have you, Professor Svensson. Thank you for choosing to have this conversation with us.
Thanks for inviting me.
Let's begin with your own academic training. You started your academic journey working on neck injuries
Yeah,
a long
that's
time
right.
ago.
Yeah.
Tell us a little bit about what brought you into this discipline.
I started my studies to become a master of engineering in Master of Science in engineering physics. And then when I was looking for a diploma thesis project, I encountered a project that I could carry out at Volvo Cars. So I live in Gothenburg, where Volvo Cars is situated. And they had a project on cars colliding with big animals, moose. It's a very big deer. It's like a rather big horse. So that's the project that I started on, and that got me into this field. I recognized that I was sort of interested in cars and also like crash dynamics and so on when I was a lot younger. I used to destroy my toy cars, and my mom was a bit upset with me. I wanted to know what I looked like on the inside, and also, I guess, sometimes trying to see how these metal pieces reacted to different mechanical load and also sort of inertial loading. You can see you can hit the car without any support, and if you hit it hard enough, it's going to deform, even though there is nothing supporting it. I think somewhere there I got fascinated about cars and also car crashes. And then when I got this chance later in life then to do this master thesis, I guess that's got me into this field.
Very nice. Tell us a little bit about biomechanics and the role biomechanics plays in understanding vehicle crashes and the effects of vehicle crashes.
When a car crash or vehicle crash or some type of an accident is a fact, and that's where my expertise comes in to protect the human body from those mechanical loads that you get in a car accident. So that's where biomechanics comes in. That we do research to understand how the human body responds to a severe mechanical loading, injurious loading, and then we try to understand how the load should be redistributed. In a car crash, you have a rapid speed change, and that goes for the occupants inside the vehicle as well. We encounter a rapid speed change, and that means that forces are applied to our bodies. And if you can apply those forces to body regions that are less vulnerable and maybe distribute the load over a larger surface of the body, you can tolerate much higher acceleration levels, much higher speed changes and acceleration levels. So that's sort of the basic principles behind protection systems, restraint systems in vehicles, or let's say helmets and other devices like that.
Sure.
Mm.
How does a vehicle design engineer think of this? The vehicle is moving, so the passengers plus the vehicle have some kinetic energy, and a crash brings that to an abrupt rest in some sense.
Yeah.
And like you were just saying, you want as little of that energy to be transferred to the passengers in the car. How does the vehicle designer, what levers does the vehicle designer have to get to where they want to be?
Yeah, so today vehicle designers have crash test dummies and also computational models, either of the crash test dummy itself or a model of the human body, so a finite element model that depicts, represents the human body directly. So those are the tools, and in a crash test dummy you have different types of instrumentation. It can be accelerometers, deflection, sensors, etc., that give information to the engineers, to the researchers, telling them whether the loads to the dummy are acceptable and or whether the system somehow needs to be improved.
What goes into designing a crash test dummy? I mean, how do you make sure, what are the parameters that one would take into account to design a crash test dummy?
Yeah, the most obvious thing is that it should have the same size. It should look like a human. It should be anthropometric. The stature, the size of the different body parts, the external shape, and then the mass and the distribution of the mass needs to be the same. And then a crash test dummy has a number of joints, just like a human body has. And the stiffness in all those different joints needs to be adapted to correspond to the stiffness you have in a human being, so that in total you get the right kinematics of the human body let's say inside a vehicle, or if it's a motorcycle driver sort of flying off the motorcycle, you want the kinematics to be right, and then sooner or later you will hit something, and then you want that contact to be representative of what a living human would have encountered.
Sure. And do they also take into account like masses of different parts of the body?
Yeah.
And match them in some way? How does one estimate that?
The old-fashioned way was actually to take the bodies from dead people and take them apart and measure the different body regions. I think today with computational techniques you can assess it just looking at the volume, the specific mass of the different tissues and so on. So you don't have to go via dead bodies anymore for that kind of measurements or assessments.
Okay. Let's talk a little bit about the global perspective on safety. Sweden is a very, presumably one of the safer countries to drive. Volvo has prided itself on car safety for decades now.
Yeah.
How did they get there? I mean, what does it take to build a safe car in the hundreds of thousands, if not millions?
I guess they started with a philosophy. I think it started already in the 1920s when Volvo started making cars. It started with a ball bearing company in Göteborg. It's called SKF. It still exists and one of the biggest in the business. And that was a spin-off from their activities to start building vehicles, cars. And then they soon realized that, okay, cars can be dangerous too. Accidents can happen. And they soon decided that safety should be like a prime feature in their vehicles. They had to be as safe as possible, and they were, of course, at that time, first of all, thinking about good braking systems. And later on also, several decades later, it became evident that crashes were bound to happen, and you had to do something about the protection of the occupants. You couldn't avoid all crashes. So then they started thinking about how to restrain people and to build it in a way that it was crash-worthy, I guess.
So I'm going to ask you a very simple question. How does an airbag work? I mean, what triggers it, and why does it keep the passenger and driver safe?
It's more or less a bag of fabric that is folded and put into either the steering wheel or into the fascia, the instrument panel. And then there is a controlled explosive charge that is explodes slightly slowly and forces a lot of gas into this bag, so it expands very rapidly. In less than 10th of a second, it's
And that is triggered by a sensor, by an accelerometer, or
yeah.
so it's more or less sensing the sudden change in the acceleration, and from that sort of triggering this soft explosion, as you say.
Yeah.
And does the chassis design also go with the philosophy of keeping the vehicle safe? What would the designer do there?
The most basic thing is to make the compartment for the occupants rigid or very stiff and durable, so that you avoid that there are intrusions into the compartment. And then the front and rear ends typically are built in such a way that they are deformable in a controlled way, so they are softer than the compartment and deform and absorb the energy and give you a stopping distance. If you run into a concrete wall, I mean, there will be a stop within no distance at all. But if you run the car into the wall, you have like up to a meter of stopping distance.
So even today, auto manufacturers globally are expected to do the stopping distance and the concrete wall tests before they are able to get market certification or to be able to sell the car in the market.
Yeah.
What does the test look for? What does it do?
First of all, it looks at the integrity of the passenger compartment, and then you have crash test dummies inside the vehicle, and you measure a variety of different things like accelerations, displacements, forces, etc., in different parts of the body. And there are like tolerance levels or maximum levels that are acceptable for the different body parts. So that's what you check in a regulatory test, that the dummy is not exposed to too severe loading simply.
Let's talk about India, where we are. We have a very heterogeneous mix of vehicles on our roads.
Yeah.
We also are just getting used to a highway system like Europe and the United States have been used to for decades now.
Yeah.
I just drove about 300 kilometers into Chennai, and it was a high-speed motorway. I could average over 70, 75 kilometers an hour. So, I'm pretty dangerous. As a driver, I could be pretty dangerous on the road. What can we learn from countries that have reached a much higher level of safetiness on roads for an India that's still growing, and we're still buying a lot of cars?
Yeah. I guess the experience from other countries like Europe and US and so on, it has to somehow be adapted to the situation here. But if you want to reproduce the traffic system that we have, let's say in Sweden, you need to separate different types of traffic. So bikers and pedestrians are definitely not allowed on motorways. And the motorways are built in such a way that you have very good dividers between the two directions of driving. So there will never be anything like a frontal collision. But also, if you happen to actually drive off and into the barrier is designed in such a way that it minimizes the risk of serious damage to the car and injuries to the occupants. I see here that you have very often barriers that are pretty dangerous to hit, even if it will prevent your car from coming over to the other side. So it protects the people on the meeting lane, but at the same time it can be, if you're unlucky, it can be a very severe collision.
So the barricade should also absorb some energy in some way by deforming.
Yeah, to some extent it should flex and deform, and above all it should be sort of a smooth surface all the way. There mustn't be any openings where you can sort of hit something hard.
So let's move on. I think, like we said, I think the heterogeneity can only be handled by segregation, because each class of vehicles will have their own driving characteristics, probably even their own safety requirements.
Yeah.
Two-wheelers versus four-wheelers.
Yeah.
Sweden had a program called Vision Zero, which was intended to bring the fatality rate down to zero. What was the thought process behind it? I mean, it's one thing for a politician to make a slogan, but I'm sure there were good engineers designing the program.
Yes. When the program first was presented, it got heavy criticism because, it is a vision. It's nothing. It's not a goal that you ever can reach, and some were almost upset and thought it was stupid to come with such an idea. But the idea stems from the philosophy that is used in the aviation industry, that every plane crash is actually unacceptable, and every means must be taken to avoid those crashes. So today we have a very high level of safety in aviation. So that was in the inspiration for the researchers at the Road Administration in Sweden to work along that philosophy. And then along with just that philosophy, that we should never accept that anyone is injured or killed in traffic, and we should do everything that we can reasonably can do and can afford to do to reduce those accidents and injuries.
Let's talk about your own research on whiplash biomechanics. Neck injuries. You've worked a lot in that. For our listeners, can you just briefly explain what is whiplash and why is it significant in the automotive context?
Whiplash is an injury to the neck that you get typically in car accidents, and the majority of those injuries occur at very benign car accidents. It can be frontal impacts, rear impacts, side impacts, and the speed change. If we talk about the rear impact, which is the collision type that is most known to generate these injuries, you only need a speed change of 15 kilometers per hour to get an injury like this. And the injury is actually, the symptoms are well documented. So there are patients coming into hospitals or to seeking medical care daily because it's a very common type of accident. These low speed accidents where you have very slight damage to vehicles, they are extremely common. The severe accidents that you test in crash labs typically they are pretty rare comparably. So the injury is very common, and it's no one dies from this injury, so it's classified as a benign injury according to the so-called AIS, abbreviated injury scale. And the symptoms are pain, first of all, the neck, headache, and also neurological symptoms of maybe you lose a bit of your sensitivity in your fingers, etc. You can have disturbance to your visual system, balance system. A lot of different symptoms that it's not intuitive how a single injury somewhere in the neck could cause all of these symptoms at the same time. And the symptoms is one thing. They are well established in a sense, but the tissue, the point in the neck that is injured, is still not established. There are a number of theories about possible locations, but if you look at the neck in a patient with any kind of X-ray or MRI or PET or all sorts of imaging techniques, you see nothing. So sometimes people that get these injuries, they have a hard time convincing doctors and insurance companies, etc., that they actually have an injury. there is always the suspicion that they are just making up these systems because they're lazy, they don't want to work, they want to get paid from the insurance instead. And then it's also an extremely enervating. It's psychologically a very tough injury because you are in pain. You have neck pain, headache, maybe constantly or going up and down depending on how hard you strain yourself. So I think it's a very tough injury, and becomes even tougher when the people around you they seem to think that, or they get the impression that you're completely fine and uninjured.
Is there a gold standard for diagnosis, apart from patient's own testimony?
Yes, I think that you can say that there is a gold standard. There are ways to establish the symptoms in a more objective way. And there are ways to classify the different symptoms in a special scale, WAD scale, and the scale is called that. And
Can this happen in two-wheeler crashes as well?
Yeah. Yes.
Because India has, probably 10 times more two-wheelers on the roads here than four-wheelers.
Yeah.
What would be something? How would a two-wheeler driver or a passenger? How could they be subject to whiplash? Again, is it very similar?
One situation I have heard about is if you fall off your motorcycle and your head, in particular if you have a helmet. The helmet is a bit elastic, so the head can bounce on the ground and cause the same type of motion and loading to the neck as you would if you're in a frontal or rear end collision.
Okay. So I think it's important that we be more aware of these things. I mean, we see crashes from time to time on the roads, but we don't quite comprehend what could be happening to the people involved there.
Yeah.
I think this is good education.
Yeah. One challenge with the injury is that it's typical that you don't feel much pain immediately after the collision. So you can be involved in a rather benign collision and you don't really, in particular, you will probably be in a bit state of shock after the collision, and it might take a day or 2 days before the symptoms become so evident and so severe so that you actually seek medical care.
Your research has also pointed to a very important fact, I think, that women may be at higher risk of certain injuries than men.
Yeah.
What led you to that conclusion?
Oh, that's from statistics, from insurance statistics. First of all, you see the number of accidents that people have been involved in, and then you see how many of those that get in the end permanent medical impairment as a classification, and females have roughly 2 times as high risk if they're involved in comparable accidents.
2 times?
Yeah.
That's quite, it's beyond, it's staggering, in fact.
Yeah.
I think, what could a regulator do to, if I'm a person involved in ensuring some form of road safety, what could I do differently knowing this?
Yeah, car design is one thing, of course, and the seat design, if we talk about rear impact, and the other restraints like the belt and the airbag should probably be somehow assessed, or their function. That doesn't happen today. But in rear end collisions, you have a head restraint in all cars, and at least in Europe and US, you have regulations, and you on top of that you have consumer rating testing that tries to assess the risk of neck injury or neck loading, if you like, in rear impact. So there is a special crash test dummy called BioRID 2 that we developed at Chalmers in my division, and that dummy, together with the injury criteria, the things we measure in the dummy, gives an idea of the risk of injury, and that is used by these rating programs.
So while, if I'm understanding you right, while we have dummies that are gender identified in some sense, the cars themselves are gender neutral by design.
Yeah.
What you're suggesting is components like seats and airbags could be designed more specifically for women drivers, is that a possibility?
Yes, I would say it's a possibility. It's not really done very much today. Yeah, so one thing is that the car is sort of it's a one size fits all. All people should be able to sit reasonably okay in a car. Their restraints and so on should protect them regardless of size, age, all these things. And at the same time, the assessment is done with. If we now talk about rear end collision and this hybrid. No, sorry, it's the BioRID 2 dummy. It only exists in one size, and that happens to be representing an average size male person.
Sure.
And something that we developed the dummy, and already when we have finished it, we said that now we need a female counterpart, because if car manufacturers use only this dummy, there is the risk that car manufacturers don't realize that they have to make the systems robust so that they work also if a person is, let's say, shorter and lighter. But that has still not happened. So we see now that cars, some of them are really very optimized for the average size male. And you can see we have manufactured one single prototype of a female size dummy of a similar kind. And when we use it, we see that some seats respond very differently with the female size compared to the male size. Other seats still, they are more robust and they give about the same performance, the same protective effect.
Mm-hmm. Interesting. Let's talk about BioRID. You've mentioned it a couple of times. It's one of the innovations that came out of your lab, your department. Tell us a little bit about the thought process and what it does. What is it?
Yeah, it's a representation. It's a dummy representation of a person. It is actually built. It's built on a crash test dummy that was developed for frontal impacts. And at that time, when I started as a PhD student, that was the only available dummy, more or less. If you wanted to look at a rear end collision, what happened to the neck and the whole torso. And I soon realized that, okay, this neck and the whole spinal system is not representative of how a human volunteer or human person responds and interacts with the seat back and the head restraint. So I started by just making a new neck, and then I saw that this is not enough. And so that there my work ended as a PhD. I got my PhD, but I got the chance to continue. I got the chance to supervise two PhD students as an assistant supervisor together with my professor at that time, and we continued the work with support from the Swedish car industry, and then we developed a complete torso with a spine that much better represents and reproduces the motion of the human, the spine, the head, and the interaction with the seat back.
Typically, how many degrees of freedom would a dummy like this have?
Let's say the human being has like 6 degrees of freedom, I guess, in many joints. Some of the joints are like restricted, but in theory. But this dummy is restricted, so it only moves forward, rearward, so in the sagittal plane. So each joint has 3 degrees of freedom, you can say.
Okay. And BioRID 2, what was the sort of the new thinking that you brought in making BioRID 2?
So it has a completely new spinal shape, and the number of articulations are the same, and the range of motion in each articulation is similar to or corresponds to a human being. So you get a motion if you're hit from behind your torso. Let's say your spine is curved, and when you hit from behind, it sort of straightens up. And so the contact with the head restraint is different compared if you would be rigid in your spine like the hybrid 3 dummy. And it's important to catch this motion to get the right impact condition or the contact conditions with the head restraint, as well as the entire motion of the neck. And it also has a neck that has the same number of articulations, vertebrae, as in a human, and the range of motion. The curvature of the neck is also made to resemble a human, an average male in this case.
I'm sure our auto industry in India is one of the largest manufacturing sectors. We produce over 15 million. We consume over 15 million two-wheelers, and about 5 million to 6 million four-wheelers anymore. And those numbers are growing double-digit. Both those numbers. And we're also adding highway. We added roughly about 13,000 kilometers of highway just last year, and this year's addition is going to be even greater.
Yeah.
What do you think the role of vehicle safety in an automotive company in India or anywhere in the world is probably one of the most important divisions before the vehicle is certified to go out? What are some new careers that you are seeing, or even old careers that are, quite attractive and remunerative in the auto industry in the broader discussion of safety?
Yeah, well, I guess the field that is growing the most now is maybe preventive safety. You want to avoid accidents from happening. There's talk about introducing automated cars. I don't know when it's going to happen. There has been talk about it now for a decade almost. Everyone discovers how much more difficult it is to actually replace a human driver, except in very clean and simplified driving situations. But what is happening is that we get more and more sensor systems and systems to help the driver make emergency braking, even emergency steering maneuvers and other things like that. And that is a field that is growing quickly and where I think there is a need for more engineers. And then all these, there's more and more electronics, more and more sensor systems and so on in the vehicle. And those systems are made for, or they can be integrated and serve several purposes. So it can be like automated driving and it can be at the same time helping the driver, alerting the driver, and even if a crash actually is going to happen, you can decide, you can see like a second before the crash happens that now the crash is unavoidable, and the vehicle with sensor systems can detect this and do something like start deploying the airbag or tightening the safety belts and a number of other things to improve the protective performance even before the crash happens. So there is a lot of need for engineers that both understand the software side and computational side and the mechanics, biomechanics, etc. So
this seems to be a profession that borrows from electronics and software as much as it borrows from mechanical engineering and biomechanics, as you said.
Yeah.
So it's somewhat unique, in that these people are not just mechanical engineers or electrical engineers.
Either you have to some degree master both sides, or you have to have those two types of experts being able to talk to each other. So I guess you can't be a pure mechanical engineer. You need to know something about computational engineering or computational science and electronics and all those things to even be able to talk to your colleagues that are the experts. And developing cars today is a very interdisciplinary business, if you like,
Very interesting. Your own research center that you operate at Chalmers, Safer, is built on a strong industry collaboration.
Yeah.
You have a lot of partners that you work with. Tell us a little bit about how does industry collaboration work? Where do you know? When do you know they're a good collaborator in some way? And when do you know, or when do you know that you are really giving them value? Or how do you build this collaboration and trust?
Yeah, the Safer Center it's hosted by our university, Chalmers University. It has roughly 40 member organizations today.
Okay.
And these organizations are like the car companies, Volvo, Scania, Volvo Cars, Autoliv is a safety manufacturer, and a number of other companies that are supplying the car industry with different types of either expertise like consultants or hardware, software that goes into the cars. And the center also has organizations that are research institutes, governmental research institutes, and other universities apart from Chalmers University. We have the Swedish Road Administration, and we have the local city of Gothenburg, their local road administration, if you like. They are also involved in this center, and the center it works in that way that it's a way to network between the experts in all these organizations. It's not a top-down organization. It's not the managers of all these organizations that meet. They allow their staff, their experts, to be part of this network, and they can meet in different constellations and form projects or work like working groups. Before it becomes a project, they can have a working group, try to gather as much information that is known about some issue that remains to be fixed, investigated. And so it's maybe a bit unique that you can have people from Volvo trucks and Scania trucks. They are really tough competitors, but they still allow their engineers to sit down and talk about things that is of that are of common interest and that doesn't directly influence what their products look like. So the domain that is outside their competitive area, there they can actually sit down and discuss also with people in the road administration, in suppliers, etc., and form projects to investigate something that that is of interest. So we have a project ongoing right now where we have both these truck manufacturers, and they are looking at the front structure of trucks and the basic design of the front structure and how it can be improved to make it safer when you have a collision between a passenger car and a truck. That's a very dangerous situation still today. With all the improvements in crash safety in passenger cars, it's still dangerous to crash with the truck, and they want to improve the situation, and they do it together. They just look at the basic principles, and then the actual implementation in the truck structure will happen internally, and there they will be competing, of course.
It's fascinating that, like you said, head-to-head competitors are sitting and exchanging notes. Is that trust built because of the Chalmers University Safer Center, or did you have a catalyzing role in that relationship?
To some degree, but I would say that this might be Swedish culture. I think it happens in other contexts as well, that Sweden is such a small country. Everyone knows each other more or less, and people trust each other and are willing to share and see that it's a common responsibility to try to do something about the societal challenges.
Would this happen only in vehicle safety, or do you think if they were discussing vehicle efficiency or performance improvement, they would still be able to collaborate across lines?
Yes, I think it's the same in many different fields.
That's fascinating. I think there's a lot to learn for us in terms of building that trust between competitors in some way, because ultimately a consortium will help us in the long run. Will help everybody in the long run.
Yeah.
You've also, as part of the safer-led interventions, you've proposed a 2+1 median barrier, and you've proposed other similar ideas to the government. What is the process by which an idea comes out of safer and actually gets implemented in the highway system?
Yeah, well, we carry out research jointly, and then we come up with ideas that solutions that we think will make an improvement. And then we have already the road administration and the people from the government side that are responsible for these challenges, these problems, and they get the information early on. They are part of developing the solutions actually, and they bring it up and they bring it to like responsible politicians and so on. So I guess everyone feels the responsibility to contribute and also the willingness to discuss and let everyone influence and take. So the car manufacturer has their needs and their restrictions in a sense. They are confined in what they can do, but they try to contribute and to explain to the road authorities and to the universities how their conditions are, and each of us sort of explain our side of the same problem, and we find solutions that work for everyone. And it's very important, me being in the academy, when I develop a crash test dummy, to do it together with car industry people, because they know what the situation is in a real crash lab, as well as how things actually can be turned into products in the end. So they help me to produce the kind of results, publish the kind of results that are actually useful. If I do it purely academically, it will be a report that ends up in the literature, and then there's a long way before it actually is taken up by someone in the industry.
So I see that involving the stakeholders, including road authorities, from the very early stages of designing the solution seems to be the sort of the magic ingredient of having this kind of success. There is another couple of uniquely Indian problems, and then we'll come to a third problem, which is more global. The advanced driver assistance systems, ADAS, is pretty much a standard feature now in most cars in Europe and in the US, but we are yet to see them on at least the mass market vehicles, which are the large fraction of vehicles. What can we do to sort of bring ADAS down to a larger fraction of cars sold in the market? I'm sure it has a safety angle.
I imagine, I'm pretty sure that all these technologies, they get more and more affordable because they are produced in larger numbers, and the industry learn how to reduce the cost for production. So they will be available in less expensive vehicles quite soon, I'm sure. The other challenge is to adapt them to the situation on the Indian roads, because my own car at home, it has a number of these features, and sometimes I can be a bit irritated because they are oversensitive. But if I would try to drive that car in this, I would get warnings all the time, and also braking interventions and so on. So I would probably try to turn the system off, because it would be extremely enervating to have the car emergency braking all the time, or signaling all the time.
So our whole approach to vehicular safety has been to build safety onto the cars and practically have an old, asphalt motorway. I've heard of these so-called smart highways, where there are sensors on the highway system as well that are detecting traffic and sort of helping drivers. For a large throughput system like India, would that be an example to sort of use to leapfrog into a more safer world? Or have you come across situations where these so-called smart highways have actually been deployed in any way?
Yeah, there are at least. First of all, we have these apps that like GPS that help you to find your way, and they also, when you have many users that are using them, they get an idea of if there is congestion here or there, and they can allow you to avoid the congestion. And that kind of systems can probably be refined more. One system that we tried in Gothenburg was to see when a congestion was building up, and actually alerting drivers further on that were approaching this congestion, and just recommending them to slow down, because there's no point in driving full speed right into that, and then you have to just brake. It's better to reduce the speed and sort of keep those vehicles that are approaching, keep them at a lower speed so that they don't feed into this congestion and just makes it bigger. So you can probably do more of that. I mean, everyone more or less has a cell phone, and you bring it with you in the car, and cell phones, they can via this system inform each other. I'm sure you can develop many more clever things like that, and there are people that are much more clever than me on that kind of things.
Sure. Well, those are interesting ideas. That leads me to the last question on this segment. The role of artificial intelligence. There's so much data coming from vehicles these days, and machine learning. What are some tangible directions you've seen where these seem to help, and where young men and women can learn and focus their careers?
The thing that I have in mind that is closest to my own area, that is that AI probably can help us to improve how we use finite element models of the human body. We call them human body models simply. And one thing we see is that in the future we would like to simulate a very wide range of collisions for each vehicle when we assess the crash safety. And to make it affordable to make all those simulations, we need smarter ways to interpret the information from this model. You can even imagine a situation where you, far in the future maybe, but maybe not so far, where you have a sensor system that tells your car that now there is a higher probability that it will be a collision. And you gather information about the obstacle that you're going to collide with. And you can actually simulate. You can run number of simulations in the vehicle on how the airbag should be deployed, how fast and with how much pressure, how the belts should be applied, how much braking, and whether you can make a steering intervention to maybe improve the situation. And with AI, maybe you and other computational improvements, maybe you can actually optimize a situation-based optimization of all those restraint systems, and AI would be an important component in that.
Very interesting. You believe safety can be more personalized, using the data and using this sort of more real-time approach. We're all globally seeing a transition to electric vehicles. Let's talk about vehicle safety, and what is the discourse going to look like with electric vehicles? I mean, the weight distribution in the vehicle is different, the chassis is a little different. What are some complications there?
Those vehicles are typically more stiff and heavier, so they tend to be more aggressive when they collide to a more traditional standard car of today. So that's one challenge, to make the structure sort of forgiving and not too aggressive to other vehicles. That's one clear challenge. Another challenge that is talked about a lot is the risk that battery is damaged and will catch fire, because those fires are extremely difficult to, you can't really do anything, but you just have to wait until it has fueled out, or how do you say?
Exhausted.
Burned out, yeah.
Is there a reason to believe the crash test dummy itself should be redesigned for an EV kind of a situation versus an ICE?
I think that's hard to imagine, because the human being is still the human being.
Okay. The dummy is more a model of the human being, and you're going to subject that same dummy in a different environment. It may react differently, but that's part of what we want to learn and measure. Let's take a step back and look at the body of work you've accomplished, and talk to young men and women about what it takes to put a body of work like that together. What sort of how has your perspective changed from being a young PhD student to now, in terms of being sort of more grounded in reality? I mean, how do you do that?
Yeah, well, I guess when I was a young researcher, maybe I was a bit more naive in a sense, of course, because it takes a while to understand the complete situation, the complete ecosystem that you are operating in, if you like. One thing that I have learned is that it's one challenge to handle the technical challenges, the technical problems, but the most difficult thing is to interact with people. If you're a manager or if you're collaborating with someone, just finding collaborators that have the same interest with you and to talk to them and come to a common understanding and a common interest is very challenging. Mm-hmm. So that is usually more challenging than the technical problems themselves. Yeah.
And you also, during the course of your work, built trust with industry.
Yeah.
That, I'm sure it's at a point where, if Professor Svensson says it, we should be giving him a good, serious ear. I mean, how do we get that? How do we get a young engineer to learn to go in that direction?
Yeah, well, you have to be dedicated to your work. I mean, you have to like it, and you should do something that you enjoy, first of all. And then I guess part of that is building trust, that you are honest with what you have, your results, your problems, so that you don't try to give an over-optimistic picture of things. And you are also honest with sort of giving critical views to if you collaborate with the car industry and you think that they are wrong somehow, you explain that to them, and you're willing to listen to them as well, because it might be you yourself that is wrong, or so somehow if you can communicate in an open and friendly manner, you will learn from each other. And you build trust, which is also very important. If I'm critical to a car company, I shouldn't. The first thing I do is to go to a newspaper and say that car company is lousy, because then they won't talk to me anymore. So you have to be aware of those mechanisms as well. Yeah.
What would you leave a young man or woman today wanting to go into vehicle safety or vehicle dynamics and then vehicle safety? These are all emerging disciplines in India. Mm-hmm. Automakers are hiring in these disciplines.
Yeah.
What is the mindset that you encourage students to develop to go into this profession?
Yeah, you have to be very curious and wanting to learn about your subject and also sort of like your subject and see that you want to contribute to something good and something good for society, for humanity. If you're in the business because you want to have a high salary or a position high up in the hierarchy, then that might not be so helpful. Yeah.
It's been a wonderful conversation. You also, what gives you? You've studied road safety for a long time now.
Yeah.
And one of the least known facts is vehicles have gotten safer over the last several decades. We tend to take each accident and exaggerate the impact of that in our own minds.
Yeah.
Where do you see this going in terms of what are some new ideas, radically new ideas that are just being experimented with in the lab, like an airbag was probably 40 years ago?
Yeah, well, things that are happening that are maybe not radical, but it's that cars will be assessed for not only the single point, the male crash test dummy in one collision, but we are going to see that they are assessed for different sizes, ages, men and women, etc. And this will be done in the computer environment. You can't manage all of this with physical testing. Physical testing will still be needed because you need to sort of anchor what you do in the computer with some reference points in physical testing still. Yeah.
What's your closing? Please leave us with a closing message for a student wanting to go into this profession.
Yeah, if you like and enjoy working with this subject, and if you do it because you want to do it for the better of mankind, then you have the right mindset, and I think you will be successful.
Thank you very much, Professor Svensson. This has been a fascinating conversation. I learned many new things.
Yeah.
This is another episode of the Professor Mahesh podcast. This podcast is brought to you by IITM Global, our platform to take IIT Madras to the global audience. I hope you enjoyed today's conversation, and you will learn some aspects of vehicle safety and the underlying thinking behind creating safer vehicles and safer roads for all of us. Until the next edition, be well, do good, and keep in touch. Goodbye.